like little blind, like black spots, and your vision will deteriorate. All right, so pay attention to that. If your vision suddenly just starts going bad, all right, and you're starting to see these spots and you kind of felt something funny in your eye, go get it checked out because it could be something related to the retina. All right, don't just blow it off as an allergy. Okay, allergies shouldn't cause all these little blind spots and scatterings of light. And then vitamin A is really important. Okay, vitamin A was the thing we talked about that's in carrots and squash. Okay, your nice reddish or like orangish vegetables. So we talked about the cutaneous tissue. Remember, that's where you tend to store vitamin A as well. Well, your eyes also store it. So remember what happens when you eat too much of it?
Turn coloration.
You turn orange. Okay, so vitamin A is a fat-soluble vitamin, which means your body's going to store it longer than your water-solubles. So you want to be careful that you not eat too much of this stuff because then you could become toxic from the vitamin A.
Really?
It takes a lot.
Oh, okay, I was like,
Yeah,
big carrots
a lot,
all the
lot.
time, oranges, I'm like, damn.
Really quick, Randy, on that, is it better to eat more carrots when you're developing, like a child? Or
Well, with kids, it's really important to make sure they're getting the adequate nutrients as a whole. Yeah. So, you know, I mean, you can contact a pediatrician or a registered dietitian and they can go through that whole thing. It's very difficult unless your kids depend on junk food and that's all you feed them for them not to get adequate nutrition in this country.
Like, when you turn an adult, does it affect you as
Oh, yeah.
as
No,
much
it still
as-
matters. Uh-huh. Yeah, even more so as an adult because that's when things start to slow down a little bit. Yeah. Yep. All right, then your neural layer, you guys, is going to be your photoreceptors. You guys remember photoreceptors or sensory neurons? And then these are the ones that what's called transduce the energy means that they're going to be receiving the light energy and then converting that into the neural signals that are then going to be transmitted back to the optic nerve. And you have all these fun different names of cells that I'm going to show you in a second. So this is where, this is going to be more the middle of the eye here, and then this is the optic nerve. This region out here, this is the retina. Here's the pigmented region that's going to have granules in it, and then everything that you see in here, this is where all those receptors are located. And it's just like a little relay of receptors that go in. You're going to have these ganglion cells, and then you're going to have a region that all of these basically merge into, and then it comes into the optic disc. And the optic disc is what they like to call the blind spot of the eye, because you can't actually see with this. Okay? The optic disc is this area right here. So when the optic nerve comes into the posterior portion of the eye, this is where all that information is coming in. This is also where the central artery and the central vein come through. And so this is your main blood supply coming into the eye, and then it dissipates internally. This is your optic nerve. So here, you don't have a retina. You don't have any receptors in this region. So that's why they call it a blind spot. But you're not blind. All right, so I kind of wish they wouldn't call it that, but it's just not an area where you have photoreceptors.
So it's not like when you look at something like that part isn't actually there, or like.
No, I mean, all of that is there. You
It's
can't
just an
see with the
opening.
back of the eye. Yeah, it's just a little spot where it connects. That's all. All right, so this is what you see when you zoom in on it. This is the one that reminds me of SpongeBob Under the Sea. Okay, so this would be the pigmented region, and then this is that whole neural region. All of these things are tied directly to the whole sensory function of your eye. These purple guys are called rods, and the yellow guys are called cones. The rods do dim light and your darks and your grays. The cones do the colors. So if you remember cones and color, that makes sense, and then the rods are the ones that do the darker light. These are your bipolar cells here that are then going to transmit the information to these horizontal cells, which then go to the ganglion cells, and then they send the information into the nerve.
Optic nerve.
Okay,
So people who
this
are
is the optic nerve here.
people who are colorblind or color deficient, is there?
It has to do with the cones. Yeah, I'll talk about that in a second, but yeah, the cones here, these are the things that determine color, right? And, you know, when color comes in, the brighter something is, you're going to be triggering those specific cones for that specific wavelength. So it's all based on wavelengths, okay? It doesn't go to Home Depot and look at all the multitude of blues. I can't tell half of them apart. All I know is it's blue, you know? Or you go to look at your different beige tones or your reds, it's like red.
That's annoying.
You know, it doesn't matter to me, but these are the things that are going to be determining this. I'm going to show you in a second how all these things work. Okay, your rods, you guys, this I want you to know, they operate in your dim light. So if I suddenly shut the lights off, all right, you would have to adjust to that dim light. There's still enough light coming in from under the door that's gonna still allow you to see in here. But if you go into an area that's pitch black and there's absolutely no light, these will never adjust enough for you to be able to see anything. Right? But when it gets dark and it's dim enough, these are the ones that kick in. And so they're the receptors that fire that then allow you to see what's going on.
So when I'm out in the desert and it's dark and I'm using my flashlight, but then also I adjust to where I can actually see things.
Yeah.
That's because of the moon.
Yeah, and it's because of these rods. And so your pupils then would also be dilated more. Because then you'd be able to see better. Your cones, these are your bright light. Okay, and then they also provide the acuity for the color vision. So your cones are for color. Okay, so your rods are for dimming, and then the cones are for color. So make sure you remember that. And then your blood supply, okay, where else have you seen the word choroid? We talked about that in the brain.
Turquoise.
Where?
Corcoid process.
No, not the bones.
Oh,
What did you say, Mary?
It's a process.
No, this is choroid.
Plexus.
Okay, choroid plexus, right? This choroid is located internally inside your ventricles, and then that works with the ependymal cells to then make the cerebral spinal fluid. So that's what you have there. So what happens is these photoreceptors are very dependent on this blood supply. So you have to have a good blood supply going into those receptors. Otherwise, they're going to die because guess what? They're neurons, right? And your neurons are highly dependent, as you guys know, on oxygen and
blood.
a good supply. So this is what you end up seeing. So this here, you can actually go to the optometrist and they can take a little picture of your eye. And what they do is, why it's important to do this, and I found out that this thing is not covered by insurance. And I'm like, well, why not? And they're like, well, we're not treating you for anything. I'm like, oh God, here we go. You know, it's tax prevention. So what this does is that it gives you a baseline of what does your eye look like. It's the health of your eye in terms of what's going on with the specific regions where your retina would be, and then most importantly, where the blood supply is. So if you have any kind of damage in terms of the blood vessels, or you're starting to get little lesions because of diabetes, they will see it on here. Okay, they can actually see where that damage is. And then this right here, this is where the optic nerve comes in posteriorly to the eye. So that is why if they do offer you that, in my doctor it's $29.99. All right, so I pay my $29.99 once a year, and I
Not
go in
bad.
and I get my eye done. All right, so get your eyes checked and have the little picture taken. I jokingly told the guy I was like getting an eye pap smear because you go once a year. He didn't quite get the joke. I turns out he was a student here. I was kind of laughing, but yeah. He goes, I know you. I'm like, yeah. He goes, don't you teach biology? I'm like, yeah. He goes, oh, that's why you said that. I'm like, yep. So here's your little eye pap.
So question, real quick,
Girls all laugh because they get that. Yeah. What?
the bottom left corner, what's it?
Right down here.
What is that? Bulging
This
little
little-
No, no,
Oh, sorry.
right there.
I don't know what that is. It'd just be how they did it. This is actually a healthy eye. No, it's not a tumor.
Tumor?
No.
Puma in the
I don't
eye.
know what
Bring
the
on
little bulge
tumor.
is. I've
You're
never
too
noticed
pretty.
a little bulge.
Cone.
You're too pretty.
All right, then your internal chambers of fluids, okay? You're gonna have your lens, and then this thing called the ciliary zonules, right? And this will separate anterior and posterior segments. So when you're looking at this, here are your little ciliary zonules, here's your lens, and then these guys, the little muscles, are called ciliary bodies. So the little zonules are ligaments, the bodies are the muscle, okay? They're smooth muscle that allow for the shaping of the lens, so they can either flatten it out or they can make it more concave. And so that's how they're able to control, your eyes are able to control distance and be able to focus on things. So we'll talk about those in a second. All right, and then remember that humor, H-U-M-O-R, okay, aqueous humor refers to the fluid inside your eye. All right, so it's a pretty boogie. It's just where the excess fluid drains in, just like you have your little ventricles. All right, when you get glaucoma, all this is compression of the retina. All right, now this can be very, very painful. This was on the list for medicinal marijuana, in case you're wondering. All right, lots of things are on. Pretty much everything is on the list these days. But compression of the retina is what happens with this, and you can imagine this probably causes a lot of problems because it's very painful. Because imagine how many sensory receptors you have in your eye, and then you have this pressuring on the retina. right? Not only are you not gonna be able to see, but then you're gonna have all of that pain coming in. So the aqueous humor gets blocked, and then that builds up because it can't drain. So this is a very, very painful condition here, and it can lead to blindness over time. So what you guys have here, this is the lens up there, and then here are your little zonules, and here are your little bodies. And then you're gonna have your little sinuses that actually help drain that excess fluid. So the aqueous humor is gonna be contained in these regions here to help protect the eye. So it helps maintain not only the shape of the eyeball, but also the integrity of what is taking place with the lens and with the ciliary body. So it's important, right? You need to have that fluid in there. Your lens is what is transparent and allows you to focus, right? This is the stuff that gets clouded up when you have cataracts, right? And these happen with age. Again, if you suddenly start seeing that your vision looks cloudy, right, and you can't really see very clearly, you're having a hard time distinguishing between the letters, right? It could be something going on with your lens. You could be developing a cataract. These are very easily treated, right? You do the surgery, you're good to go the next day, right? It doesn't take a long, long time to recover. And this is what the cataract looks like. So I always think of dogs with really old eyes, right?
Yeah,
You
my
could
dog-
have them,
My dog's
cataract
like-
surgery if you wanted.
So, if the lens is avascular, how does it get us? So why lobster?
It
Or is
diffuses.
The whole thing, or?
Yeah, the white.
Don't they just make it?
Can you go back real quick, Reg?
Pull it out, put a new
Uh-huh.
one in,
Reg,
pretty much?
can you go back real quick? The cloudiness.
Oh, that one, that whole, okay.
Yeah,
Yeah.
you get the cloudy eyes.
Okay.
That's your cataracts.
All right, then the light, in terms of how it comes in, you guys, it comes in through wavelengths, all right? So you guys all know that light has its own wave, but what we see is called visible light. So your rods and your cones are gonna respond differently depending on what wavelength is coming in. So this is what you look for, okay? Your rods are gonna be here, these are your bluer cones, then you have your green, and then you have your red. So the cones are tied to color, the rods are tied to your darks. So darker light is gonna be right about in here, and then the rest of it is mostly all with the cones. So your ability to distinguish between colors has to do with what wavelength is coming in, and then how many cones become active when you're looking at that particular color. Right, so then refraction, that is what happens with the light ray as it comes in, it bends. And then the bending allows it to move to the other medium, which then is gonna hit those receptors, and then it comes in at that oblique angle. You need that light to bend. If it doesn't, you're not gonna be able to see what you're looking at. All right, it's just like in a swimming pool, when you stand in it, it looks like you're bent. When you put the pole to clean the bottom of the pool out, it bends. That's what refraction is. Right, you guys wanna calculate all this stuff, you can take physics.
I don't know how we're
Did
gonna
that
get
once,
through this
don't
all.
wanna do it again.
Times it.
All right, then your
120.
lenses are necessary in order for you to be able to focus
Missing an
what
hour.
is happening with the refraction. All right, so when the image comes into your eye, it forms at the focal point, it's upside down, and it's reversed from left to right or right to left. So it's kind of goofy. This is what happens to light when it comes into your eye. So no wonder we get confused, right? So here's what you're looking at, here's how it's coming in. So everything that's focused here is going to kind of bounce and then come to the back. And then your lens, what it does is that it actually gets these things to bend in the right way so you can actually see what is coming in. And then based on that, then it'll synapse and then trigger the stimulation of those rods or cones, depending on what it is, and then you can start making sense out of what is happening.
And it does that with the sensory, or the suspensory equipment?
Well, they bend according to what you're trying to focus on.
Okay.
Okay, and to me, it's just amazing how like we have this autofocus mechanism inside our eyes that does that. But the light comes in, it's refracted at the cornea. So as the light is coming in, it reads that, and then the lens, depending on where it ends up in the back, that's how it ends up focusing. And it does the best it can, but it's dependent upon those little ciliary muscles to be able to do their job, to bend the lens the way it's supposed to go. If it can't do that, it could be because of the shape of your eyeball, or it could be because those muscles are just getting weaker. So what ends up happening is then you have to adjust for that by wearing glasses or contacts, or they can do the different surgeries. So the further away an object is, okay, the rays are going to come in more parallel. And so you won't need a whole lot of refraction.